Ça marche. Your Slido is active. Perfect. Do you want also that I control the time? Yes. 5 minutes. They have 10 minutes. No, they have 15 minutes. 15. So 20 minutes for Florian and 15 minutes. Yes, can you connect us again? It fell from So we start with you? No. It's with Florian and it's okay. Oui, ils sont là. Oui, il faut prendre des micros mains. Welcome everybody for this second part of the afternoon sessions. I'm privileged to be with you today. It's a very important conference, Indetech 2022, every 2 years, part of the French European presidency and organized together with CEA and the European Commission. So it is the place to be this week. Don't forget that we have the Slido. You can ask questions to our speakers. And after green manufacturing, few minutes ago, we will explore the biological work, the biotechnologies, and how we can be bio-inspired to create new materials, new processes. Indeed, we have lost contact with nature in our urbanized and industrial world. From biophilic to biotechnologies, our speakers will explore how we get inspired, what we miss, how we complete our perception of nature, what it creates for us, and how it inspires us. I would like to welcome Florian Bougaud. Florian Bougaud is head of design at Tarkett. Tarkett is a flooring manufacturer. And I asked Florian to tell us about what is to be a designer, connecting us with nature, and what lessons we can get from that. Florian. You have the micro?
Yeah, I need to put it on. Somewhere.
Has to be turned on here, I think. The screen over
It's good. It's good. Yeah. Thank you. Good afternoon, everyone. Thank you for meeting to have something for term.
No, I think it is like this.
Okay, that's going to be fun. Thank you very much for coming over. My name is Florian. I'm art director for Tarkett, and I am a designer. I used to be an engineer, so I know what you are from and what this world of technology is about. Before we start the presentation, I just want to make sure that we know what designers are doing. Very important to understand that we are not artists. You know, I get this compliment every day in my company, and no, we are not. No, what we do, and this is true, is that we're trying to build a bridge between reality and a dream, sort of a dream or a projection. And we're doing that back and forth. So that's maybe why we are a little bit perceived as dreamers or as artists, but we are not artists.
You can see in a bit more because I cannot see it in the presentation. It's a PDF.
I think it doesn't work with
Okay.
the PDF.
Okay.
Only with
That will work.
PowerPoint.
Okay, good. So, important to understand that, oops. Okay. Important to understand that, so our work is about, making sure that we are building a bridge between reality and the future. And what it means is that we are trying to solve some problems for, society in general. And our focus is really to answer the needs of users. So we talk about user scenarios, we're talking about focusing on how people are living and how they are behaving. And in that context, there are many, many information that we need to capture. There is technology, and we are working a lot with our R&D department within Tarkett, of course, an innovation team. We're talking about marketing, the business, but we also talk about culture. I can tell you that cultural habits are very much different from Sweden to Italy or Spain or Croatia or, well, you name them, And the habits also are different from one generation to the next. So there are different things that you need to take into account to build a solution or a product, actually a product or a service, for the matter, that you need to think about. So we need to investigate this. We need to get into contact with the users. That means we need to step out of our lab or out of our studios and go into the field and meet with, well, we have many users, actually. We have you as a consumer. We have prescribers like architects who are building buildings, who are using our floors. We also talk about distributors, people that are selling. So they are not actually using it or prescribing it, but they are kind of prescribers in a way. We are talking to the mayor of Grenoble, Mr. Yeah, of course, because municipalities, they are building schools and they are refurbishing schools. We are talking to janitors who are cleaning. We are talking to hospital engineers who are refurbishing some and updating. So we are talking to a lot of people. That this is our job as Tarkett designers, but this is the job of any designer. So just to reveal a bit the complexity of what we're doing, and again, it's just to bridge from what we could project as a solution to this audience to a real solution that's going to be life. And one of the key things, the key traits that we see in the in the past years coming very strong is this notion of biophilia. So just to give you a quick, this is a definition by one of the fathers of what we call biophilia. His name is Stephen Callard. He was a professor at Yale University. This is a quote from something like 1978. And it's basically at that time already, and we think of the hippie movement or kind of these kind of things are came across in the 70s, but then they were already realizing at the time that we were living and trapped in cities, in buildings, and we were already lacking the benefits of a contact with nature. But we're talking here about scientists. We're talking about here some researchers, and this goes just beyond by saying, oh, let's put a plant in a space. They proved by analyzing the behaviors of people in, say, in hospitals, that having biophilic, and I will detail you that afterwards, biophilic elements would improve the recovery of patients. Similarly, they would prove that the confidence or the rate of learning of students in biophilic schools would improve as well. And I could go on and on and on with how people would better concentrate at work or feel better about themselves at work because of these biophilic principles. So let's go a bit more forward. And basically biophilia can be translated in many, many things. Some things that you already know, I'm sure. One of the first things, and I mentioned it already, is like contact with nature. That's a very basic one. It's like, okay, can I see something out there? Can I have, something that's fairly obvious? And you'll see that it's not that obvious for a lot of things. But it's, okay, I can see it. And this is very appreciated to see the mountains over there, for example. And I think that people and the students grown up like to see that. Something else is about using natural materials. And I can't tell you, I've just finished a study recently about the wants and needs of consumers from Sweden to Spain, and everybody wants parquet wood, oak, chêne. And it's like, okay, you know that we have a little problem with supply of oak at the moment, and wood is like a bit complicated. But then anyway, no, everyone wants that because it's the epidemic of the natural material. And here you see marble, and marble is very big now. It's more generational, but it's quite very big. Something else, evoking nature, drawing of nature inside. I mean, I don't know if some of you visited some castles of the Renaissance in France. If you go there, you see some tapestries of Aubusson, and what you see there is just like description of the forest, the works in the fields, the outside in. Okay, we're there. And there are so many other details, and I'm going to show you some, of course. And then finally, it's like, blending in is another principle of biophilia, is that, you are one with your outskirt. It's like, for instance, there are plenty of very good examples of houses that are built that almost blind into the landscape. And maybe there's an extension to that the materials that you use could be coming from an area around something like 20, 30 kilometers around. And you see that in many traditional habitats where you would buy, you would say mélèze here for the roofs. You would see lows in some other areas down the south. You would see ardoise in Brittany. I'm talking about the French architecture here. You would see, I don't know, bricks or brick roofs for, and we see that the local used to be the main principle. It is not anymore, but it has to do with this kind of intention to blend in. And then, okay, just a few examples, and this is the Edfu temple in Egypt. And when I was talking about evoking nature in the sense of being part of our lives and how this is populating our areas, this is very important. Well, there are countless of things like that. I mentioned the tapestries, but we could have mentioned like just the legs of the furniture that you have at home, or even, I don't know, chandelier. I mean, it's everywhere. Look at it, it's everywhere. Even the shapes of some just like very useful objects, like a toothbrush or anything, it could be remembering of something else. Okay, I was mentioning like the contact to nature earlier on. This is an example of a hospital. It would make sense to have natural light in, and of course, it's very beneficial in many ways. One of the key things about natural light is that because the light outside is evolving during the day, from the morning to the evening, then you have a change of the setup or of the aesthetics inside. It brings dynamics, and that dynamics, we call it circadian rhythm, is extremely important. If you start to think about some principles today being studied for Alzheimer's disease, circadian rhythm is extremely important for the body, extremely important for our behavior and our wellness. Now, if we look into this, I don't know if you have any remembrance of some hospital rooms or hospital patient rooms in, let's say, the 70s, 80s type of buildings. Interesting is that probably the window would stop just right there. So if you imagine that you're lying in your bed, guess what is the probability that you can actually see anything from the outside? Close to zero. This is, when I talk about new principle, it is so simple, but just that very basic observation gives you an idea of what we mean by biophilic principles. Something else, like we do print things at Tarkett. We print materials, so, well, architects would say that we do fake. Yeah, but, well, we do fake, but we're not the first ones. Like, that's been existing for all over and over and over a very, very long time. And you saw it in Edfu, they already did that fake, type of papyrus trees and so on in Chenonceau and so on and so forth. But then what we do is that we do it's better and better and better. So for instance, right now we are not anymore using cylinders to print, we're using now digital printing. So there it goes to the connection with the technology. It's very, very high-tech technology because I can tell you that it's, of course, it's a production with a very strong output. And what's interesting here is that now we're able to not reproduce the planks that we print anymore. So that means the difference between the decor that repeats, it doesn't repeat anymore. And that is fundamental to a natural principle that nature, of course, never repeats itself. And that you can really feel when you start entering the room. And this collection that we something like launched like a year ago, it's a blast. I mean, people like really realize the difference. So here we have, again, another principle being applied to something that's fairly, common. And also nature is to the details. Nature is not perfect, or at least its perfection is in its defects. And of course, when we start to see the nuances, and we have now also the technology to render that nuances. And this is part of the dialogue that we have between the research and us as design, because for us it's very important to be able to show these defects or to pretend that they come randomly as well, so that the effect that we do and when we start printing things is actually part of the decor itself and not being perceived as a defect, but like it's natural. Because the main thing that our clients and typically architects are asking from us is we want to make it look natural. So basically our mission, one of our missions today when it comes to these kind of decors, like marble or stone or wood that we saw before, is to make it more and more, let's say, natural. So I guess that in 10 years from now, we will generate new planks of wood or new tiles of marble like this and print it right away. And it's never going to be the same, just like nature, because the computer powers the print technology that we'll get there. So now let's turn on to another way and talk about natural materials. Let's talk about one very famous and actually kind of misunderstood material, which is called linoleum. I'm sure that you've heard the name lino, and linoleum is named after linen, oil, oleum, linen. So it's a natural material. Huile de lin, and it's an actual biosourced material. So of course, in the course of history, when vinyl, PVC, plastics came over, especially after Second World War, everybody wanted to this new technology, this plastic were so easy to print or to install, and basically it took over linoleum that was actually born back in something like 1870. Frederick Walton in the UK built the first plant. Our Noni in Italy plant is from 1898, just to give you an idea of how old this material is. And basically the idea behind it was like, okay, it's not a plank, it's something that's resilient, so it's flexible, and it's easy to install. You have large surfaces, it's extremely resistant. And well, today, it's an inspiration for designers. It's responsible choice for architects, and I'll explain to you that why. And it's what we call it now at Tarkett, naturally modern. So it all starts off with some very basic elements. So linseed oil, I mentioned it. Some wood floor, cork, pine rosin, and basically you make that paste like I shouldn't say that, Nutella. And you basically spread it on a very nice jute fabric, and like you calendar it on top, and that's what you get. Very easy, right? Of course, before doing that, you need to add some pigments for the color, and of course I mentioned like laminating or calendaring. This is inside our plant, so you see like this beautiful natural material getting flowing around. Because, well, I'm sorry I didn't bring a spray, but I could give you the smell of linseed oil. It's wonderful. And then, of course, there are different categories of pigments. This is where we're going to get into our topic of the day in terms of selecting proper materials for our current, today challenges. And we wanted in the latest collection, and I'm going to show you like a piece of it, to reach the Cradle to Cradle Gold certification. And that certification is extremely stringent on the type of pigments that you select. Of course, the artificial pigments that were so successful when the Prussian blue was invented, or these kind of very bright colors, because before that, I mean, everybody was pretty much dressed in gray or grayish or grayish gray. Seriously. And it's only like starting at the 18th century that the bright colors really showed up. And of course, these are ones that we use quite a bit. Now here, where we want to do is like to reach that, and to reach that, the Cradle to Cradle, the EPA is very strict on what you kind of pigments you need to choose. So this is where the want and the meets, meaning that we had to pick up some pigments that were existing as natural elements. That doesn't mean that we are using natural ones, that we're not going to our backyard to dig up some oxide, iron oxide to do it. We actually use a like synthetic one, meaning that we are using something that is purified so that we can actually use it on a industrial scale with the quality control, of course, but the molecule is actually existing out there, mixed with other things, of course. And the result was beyond our expectations with Valérie Pavard, who's the designer of this collection that works with my team, because the colors that we obtained by having this constraint, like we managed to make a very beautiful collection. This is the palette. I'm sorry for the color, but it's really wonderful. I mean, architects are just like screaming for it right now. We are very happy about this. We get some awards. We got an award like yesterday, I think. And it goes on and on. So that makes that bridge that was about, okay, meeting a general want for biophilia, together with a natural material, but then going a bit step further with researching the proper elements that will go that way, and then get the certification of the product, but also of the plant, because I forgot to mention that our Narni plant is also operating on maybe, I don't know how many cubic meter of water every year, but something like 3 cubic meter of water. That's only spent. Of course, there's more water circulating, but just like, we're just like, it's like closed loop. We are operating also on solar panels, and we are recycling pretty much everything that we can. Forgot to mention that this is a material that is recyclable post-use. That means you install it in a school for 20, 30 years. We take it back, we separate the jute, we get back the cement that's on top, and we make a new nylon out of it. So this is circular economy. This is Cradle to Cradle. And we're very proud of that collection, and I hope you enjoyed this presentation. Thank you very much.
Yes. Thank you, Florian. I think now you know more about what is under your feet, and especially this beautiful linoleum, which is really inspired by nature. More than 100 years old technology, meaning that as well in a conference dedicated to current technologies and technologies of the future and circular economy, materials that have been used for many years still have a role to play. So that's very important as well, that we do not forget the capital we have in our industries that are quite traditional on that aspect, but are really inspired by nature and using biosourced materials. Now let's jump in the biotech. I think it's very important now to see how much the biological environment is integrated in research. We learn so much from the possibilities of nature, and we are using microorganisms. We identify new way of producing molecules thanks to microorganisms. And we need to have the different steps from research to industrialization. There is something very special, which is the pilot phase. And I'm very happy to welcome Tanya Meyer, who is leading the laboratory of biomaterials at the European Biobase pilot plant. And she will explain to us what are the new technologies she is preparing for her customers.
Okay, thanks Mariam for the lovely introduction. So now I check the mic is working. I will jump around. So my presentation will be about industrial biotechnology. Is it really the smart solution to circularity? And how is it the smart solution to circularity? So I will start actually my speech with, the devil in the room. So the devil is the fossil resources. Fossil resources, crude oil, gas, everything that we extract from nature. And why is this the devil in the room? Because the linear approach that we have is not sustainable. Aha. So I would like to point to this linear approach that we are mostly using today. And as said, it's not sustainable for many kind of reasons you probably know. It's also called the black CO2. So CO2 or carbon itself is not bad. It's just the circle of time with the black CO2 that is not so good. That is not sustainable. So how can we turn the fossil resources to renewable resources? So this is when we talk about green CO2. Why is it green? Because it actually takes into account biomass that is produced on Earth, like either from agricultural side streams, forestry, agricultural side streams. Biomass can be converted into food or energy, into chemicals, into products. And the nice idea is to use this biomass changed materials, not as a waste in landfills, but actually to reuse it and recycle it so that we get a really large cycle of the biomass. Who knows the colors of biotechnology? Because now I will talk from bio-based economy to biotechnology. So did you ever hear about colors of biotechnology? Like, yeah. For example, there's this color of technology, biotechnology. There's this color of bio, the red one. No? A blue one, a green one. So what does it mean? So just to set the scene for you and give you a little bit of background information, the red, what we call red biotechnology, is all about health applications in medical biotechnology, for example, for vaccines, for insulin. The green biotechnology is also a term. It's all about what can we do about agricultural. So it's the plant biotechnology to make crops more resistant against diseases and insects. In the last coming years, there's the blue biotechnology upcoming. So everything that is related to marine resources, also from marine enzymes. And then there's the white biotechnology. So the white biotechnology is also called the industrial biotechnology, and it really refers to everything that is related with the use of microorganisms and the use of enzymes to produce any kind of chemical substances, materials, and bioenergy from really renewable resources. So I would like to give you some examples so that you know what I'm actually talking about. So here on the left side, you can see some examples for biomass. So for example, agri-industrial products, bagasse, beet pulp, algae, paper pulp even, cellulose, also syngas, so industrial waste gases are kind of, not biomass, but it could be a green syngas, so it contains green CO2. corn stover vegetable oils. And then, like magically, there's on the right side the refined product. So what can industrial biotechnology produce? For example, it can produce industrial enzymes. It can produce biosurfactants that you have in your washing or in your detergents. Solvents, bio-based solvents, bio-based chemical building blocks, polymers, proteins can also be produced now with fermentation, nutraceuticals, and flavors and fragrances. And also pigments for paintings or additives, resins, etc., etc., etc. So how do we actually come now from the biomass to the refined product? So I will show this to you on a couple of technologies examples that we use at the Bio-based Europe pilot plant. So that's why I call it the one-stop shop. So we actually at the Bio-based pilot plant can start with the pre-treatment of the biomass, so mechanical and chemical treatment, pre-treatment. And then there are different, let's say, conversion technologies here in the middle. So biocatalysis using enzymes, fermentation, also gas fermentation, using microorganisms, and green chemistry using, let's say, only low pressure, low temperature, and kind of mild conditions, mild solvents for the extraction process. But there's not a refined product without refining the end product, without purifying the end product. So the downstream purification is really an incredible important step to have the refined product, for example, that I showed one slide before. So you can already think about refined product with biorefinery. So biorefinery is actually analogous to a refinery that was using petrol or non-renewable sources and convert them into petrol and other gases. So now I will make a little bit of a jump towards the technology readiness level. Do you know the TRLs? Yes, since long time, I know. That's very good. But why or how do the TRL relate to actually bioeconomy or biotechnology? Because probably you're mostly coming from manufacturing. This system was invented in the 70s by NASA. Then in 2008 it was also used with ESA, so the European Space Agency, because there's a European one. And I think the last years in FP7 also it became a very common used European jargon in the European Commission for the call topics. So European Commission is using it for the funding, but also, and we see this more and more in the last couple of years, investors are using TRL. And I think this is really important to keep in mind for the development of the biotechnology. So I will change that. So we look a little bit sideways now. And I actually put this scheme over it. So I know, you know it all. It's the valley of the death. So what does it actually mean now for biotechnology or biotechnology development? So I recap shortly on this corner when the time is young, the TRL is low, we have the discovery of the research, we have a super high technology risk, everybody's happy working in laboratory, so everybody's happy working in laboratory because they're scientists. We have an infrastructure that is capable of producing excellent science at the laboratory scale. But now we are coming here from this side, there's the market. So we need to produce tons or kilograms per day, per year on our material that we actually want. So here the requirements, the capital requirements are very high. Also, there are not so many researchers anymore from the mindset. They're entrepreneurs, they're business manager. So it's a full different organizational mindset on this corner. And the part in between is a very critical part when the technology risk is still high, but also the capital requirements are super high. because somehow these two sides needs to match. And this is what we call actually here the valley of the death, where a lot of things are going on and even more things or organizations are actually failing. So in order to overcome this, how do we overcome this? So but what is the solution? Like, how do I turn a scientist into a businessman? We pray. So here we're talking about pilot infrastructure or demo infrastructure. We're talking about still scientists, a little bit of engineers, operator, business development. All these things are kind of mixed up. And one solution, of course, could be a shared pilot facility. So that's the bridge that I make to the Biobase Europe pilot plant. So the Biobase Europe pilot plant, that's really the full name, is a multifunctional open access scale-up facility based in Ghent, Belgium, for bio-based products and processes. So it was founded in 2008. It's operational since 2010. At the moment, we have 145 or 150 employees. I don't know. We are increasing staff members 20 to 30% per year. So it's really accelerating. It's a pilot plant that operates globally. So, of course, we are in Europe, we are seated in Belgium. We like Europe, but actually we think globally. So there are a lot of customers from Europe, USA, and Asia. We are a non-for-profit organization. So that means actually every profit that we create, we reinvest in the new infrastructure. So how does this actually look like now, for real? I would like to have a pointer. So here, this is not the Biobase Europe pilot plant. This is actually part of the North Sea port that comes with the canal here to the right. You will end up in Terneuzen in the Netherlands. And here on the left, you will end up in Ghent in Belgium, in the city. So this is, we call it the bioeconomic valley, because here's Alco biofuel, here's Cargill, here are Eurocellulose. There is Electrabel with the cooling tower, and Electrabel is a wood processing electric company. And this little part on the right, the other right. So, our ambitions are big, yeah? This is the pilot plant. Okay, I will make it easy for you. I will zoom in a little bit. So we did not build everything ourselves. It was actually an old fire brigade facility that we used. And we have different process halls for pre-treatment, biocatalysis, fermentation, large-scale purification, green chemistry. We have different certificates for project management, for corporation management, for food scale, safety certification. 29 running European projects that we are quite proud of. And in the last 10 years, we did around 500 projects for around 150 companies. So this is also already the modus operandi Biobase Europe pilot plant is working on, with the consortium-based projects, like the European-based projects, and the bilateral projects. About the bilateral project, I cannot say much, so that saves some time. And the consortium-based projects, we have quite some experience with, of regional projects, Horizon 2020 projects. They are partly subsidized and partly privately funded, so we use them to really build expertise, to increase value chain, and it allows us also to communicate and speak about some of the results. So I will show you some trends quickly about the ecosystem development, about bio-based building blocks, and bio-based and biodegradable plastics. It will fit into 5 minutes. So one example is the Biomac project. It's an open innovation testbed example about the, let's say, approach to any kind of market readiness and production of nanostructured bio-based materials. So here the idea is to have a couple of pilot lines really starting from the biomass fractionation, going over intermediate chemicals to really final enabled biopolymers. So there's an open call coming out next year, so you need to keep that in mind. Here you can see there are a lot of partners, 33 partners are involved, and the University of Thessaloniki is the coordinator. So it's really a large project. That's a super nice one. So Smartbox actually covers or starts also with the lignocellulose biomass that will be fractionated with the technology from KU Leuven through their reductive catalytic fractionation technology. And then we have a computational engineering company on board, Zymbul from Spain. I'm standing in the way, yeah? And they can actually scan 100,000 mutants per day to find the right mutation for the right enzymes. And these enzymes actually will be used to take the lignocellulose fractions for, like, example, lignin oil and pulp, and produce different chemicals like vanillin, polycarbonate building blocks, and FDCA. So yeah, what is important here, they are all partners on board from large industry, SMEs, and research organizations as well. Because yeah, we need the IP. Glaukos takes up a very highly discussed topic, the microplastics and also the pollution of the ocean with the fishing gear. So here we actually try to use fermentation technology to produce European source building blocks. These building blocks will be composed in a new designed polymer that will be then spun to yarns and to fibers, and then we will actually produce a fishing gear, or as a second application material, a textile, maybe a t-shirt or something, we don't know yet. So when we have produced this bio-based building block, it will also be checked for end-of-life solutions, for biodegradation and bioecotoxicity. So again, here is also the full circle with all kind of partners that you need to really establish the circle from cradle to grave. The last example is actually, it started as a private collaboration with LanzaTech. So they approached us with their technology in 2012. And now they're actually building a facility in Ghent with ArcelorMittal. So ArcelorMittal is the largest steel manufacturer in Ghent. It also actually lies on the canal that from the picture that I showed when you went to the right. So LanzaTech technology will actually use the steel or off gases from ArcelorMittal to produce ethanol with their patented technology. So this is the picture. I think it's not too old, maybe end of the last year. So it's a 195 million investment, so you can imagine what's behind of this. If you're interested in more of the projects that we have a really nice YouTube channel with like 50 videos from all kind of projects. And if there are any questions, I'm happy to take you. Thank you.
Thank you, Tanya. Thank you, Tanya. So, months later, years later, we will achieve the industrial scale. And I'm welcoming Keith Josias. Keith Josias is the Senior Director of Research, Development and Technology at Total Energy Corbion. And Keith will tell us more about the production of polylactic acid, a biosource plastic, recyclable, industrially compostable, at industrial scale.
Thank you very much. I think it works. Good. Right. So thank you for the invitation to speak here for all of you, to spread the gospel of PLA and bioplastics, as we used to say it. It's not a new material. And I'm actually quite happy that Tanya was before me, because we were there in this valley of death. Yeah? So like 10, 15 years ago in Corbion, we started this adventure. Can we make PLA, a bioplastic, can we make it on a large scale? And the first thing we did was build a pilot plant on a 1 kiloton scale, because you need to make all the mistakes. That's what you do. You have the business developers and the scientists, and it doesn't work, and the business model doesn't fit, and all the things that you can think of that go wrong, well, there's actually more things that go wrong than the ones you could imagine. So that's why you start small. So I can recommend, go to Gand. It's a nice place, and they have a very good facility over there. Now PLA is like maybe even 25 or 30 years old. So why do I still need to preach the gospel to all of you? Well, actually, and I'm going to be a bit provocative, I promised Miriam, I was very disappointed getting at this conference at the catering, and I saw them using these kind of coffee capsules. This one is even worse. It's from aluminium. Now you can say that's easy to recycle, that's true, but smelting aluminium is not very energy efficient. And then what do you do with all the waste, the organic waste that is inside there? Now the other one is made out of plastic. Now we can do that in PLA as well, which makes it fully compostable, but here is an aluminum cap still on it. So this is half a solution or something like that. So yeah, well, I saw that and I was like, this is not good. I mean, if this is the speed at which Europe is innovating, then we are losing the game, huh? And then there were the cups. Produit contenant du plastique. This product contains plastics, and then it's red with a big cross in it. So plastics are bad. That's also the message that we hear a lot. We need to do a little bit on our communication skills, I think, as a bioplastics industry, because this is not what we should be preaching. This is the wrong message. You can make this cup fully bio-based, recyclable, and compostable. No problem. It's been done. Why are we still using these here? That's my question. Sorry, let's go on. I need to move around a bit, so that's fine. Like this? Yes. My mama used to say, properly introduce yourself. So this is our company, Total Energies Corbion, Total Energies Oil and Plastic. Corbion Biotechnology, white biotechnology, as was properly explained to us. So bio-inspired lactic acid, the LA and PLA is lactic acid. It's a natural molecule. It occurs even in your own body today. You have lactic acid. It's the molecule that you make when your milk goes sour. Lactic acid. Yeah? Simple as that. Now we do that on a big scale. On one site in Thailand, we have Corbion producing from the fermentable biomass lactic acid, and we make plastic out of it. Basically, that's what we do. I hope this is pretty clear. And you can do a lot of different things with PLA. We talked about coffee capsules a bit in my opening statements, but I've got the nice ties made out of PLA. You've seen packaging bottles or food packaging containers here. I mean, in some of the supermarkets, you can actually buy those kind of things where the tomatoes or the cucumbers are packed. Please do that. So it's a versatile material. You can use it for many different applications. There was another Nobel Prize winner from the Netherlands. He said, there's no bad materials, there's only wrong applications. Yeah? So keep that in mind when we go through the slides. PLA is not the solution for everything. Yeah? You need to be a bit smarter than that. But still, it has a lot of interesting properties, I would say. It's sustainably grown. Yeah? It's 75% less global warming potential if you use PLA instead of like polystyrene, for instance. It has properties which are a bit in the middle between polystyrene and PET, and even to the PP kind of property portfolio. We can make it heat resistant. It's mechanically recyclable. It's compostable. And it's also chemically recyclable, which is an interesting case study, which I will show you later on the bottles. So we have options, end-of-life options basically with this material. And I'm saying PLA, but for bioplastics in general, you could have the same argumentation, and I think it's important that we realize that. From the end use, you yourself, a consumer, there needs to be some sort of a return logistics scheme. That could be a deposit scheme, but it could also be the green bin on the street when you put out your trash. Reuse, well, a coffee capsule twice may be a bit difficult, so that doesn't work, but it is easy to mechanically recycle 6-7 times. It has been proven scientifically, and you need to add a little bit of chemistry maybe to keep the properties up and going, but it is possible. And maybe you don't want to go from a food packaging application to a food application again, but then why don't you make stationary articles or the cover for an iPhone out of it, something like that. Now, if that doesn't work for one reason or the other, and you really need the virgin properties, like food contact, for instance, then you can also chemically recycle it. If it's contaminated like the coffee capsule, where did I put them? You were paying attention, good, good. If there's a lot of organic material, like a yogurt cup, a yogurt pot from there's a lot of water and some yogurt left, organic material, the coffee capsules we talked about, but also when you're doing your household cooking exercise, you cut your potatoes or you slice your bananas or whatever you do, there's always some residue. If you can just put it with your packaging material in the green bin, instead of incinerating it, evaporating a lot of water and wasting organic residue that can be easily composted, PLA or bioplastics are a solution for that too. Yeah? So you can actually choose the end-of-life scenario, and I think that's the magic word, the end-of-life scenario, starting from the design, thinking of what will be the end of life for this application, and be smart about that. I think you've seen most of these. Let's not go into a lot of detail, but for instance, a tea bag is an obvious example of diverting organic materials from the landfill or from the incineration to composting. So we can make tea bags out of PLA and not out of polyamide. You can also do it in paper, by the way. But these are the typical end-of-life options for diverting organic waste. The stickers, I hear you saying these stickers. I mean, you have an apple and it has this small sticker on it. Why the hell is that in the first place? I mean, I hope people recognize this is an apple, yes? Okay. But it's not compostable. So if you peel your apple, suppose you do, or you throw away the residue, it ends up in the wrong place. Huh? So if we need to put a sticker on it, please make it degradable. One example about chemical recycling. So we have a project with the company Sansu in Korea. And this is about the reverse logistics and how you can do that. Yeah? So it starts a bit, it's Korean, so sorry for the English-Korean translation. Recovery actually means we have recovered the material and made virgin again, and then we start to make bottles, we consume them, we use the collected, we collect the bottles that have been used, so they are online ordered. That's maybe good to make the system understood. So you order a tray with bottles of water. They are being delivered. Yeah? Then, when they deliver the new bottles, they take back, simple, smart, the used bottles. Those are checked. The reverse logistics is basically the new bottles with the old bottles in the same truck back and forth. And then it's collected, sorted, dedusted. PLA pellets are made out of them, and we put them, basically, we put them back in our own factory and make virgin PLA again. with all the original properties, including food contact, because you don't want your water bottle to taste funny. Huh? So, lots of text here. People know pyrolysis, as in you take polyethylene and then you basically heat it very high temperatures, it breaks apart, and then you have you put it back in the steam reformer after you put it in the cracker, and then you have new molecules, but it's not plastic yet. We can just simply basically put a bit of hot water, PLA. You only need to hydrolyze it because it's a polyester. You get lactic acid and you make new PLA again. It's as simple as that. So the example is, ta-da, put on the kettle for the tea, or you have a naphtha cracker and a steam reformer for the pyrolysis part. Our colleagues in Total Energies, they don't like this picture, because that is a bit confrontational. Although Total Energies is also building a pyrolysis plant themselves to make biofuels, the Biojet project, and so on. So they're busy on this. Now, there's a couple of messages I wanted to give today. We think that bioplastics are actually enabling the circular and bio-based economy. And then we get a lot of pushback from the existing industry saying, yeah, but your bioplastics, they are actually polluting our systems. And of course, they are much, much bigger than we are, so we have to treat them very careful. But all the technology to properly sort the materials does exist. So it's a matter of size. It's just so small today that it is not very attractive yet for the big waste handling and sorting companies to extract the bio-based materials out of it, the bioplastics, to make actually some money. I mean, we're all in the game to make a little bit of money. So it's not so attractive yet for them to do it right now. Now, then you get into a discussion, yeah, but then if still a little bit of your bioplastic ends up in PET or in polypropylene, that causes a lot of problems. Well, we tested that, and up to 1 or 2%, which is far beyond the capabilities of what the sorting system can actually do, there's no negative impact. So that is two myths debunked, not true. If you think about about circular economy and bio-based, sometimes it's like people position it as if it is one or the other. And we actually say they're both good alternatives. It's and or to get to circular and bio-based economy. That's what the European Commission also says. So we're actually saying, you could say, we need 30% recycled content. I think that's a noble goal. It should be close to 100, obviously, in the not so far future, hopefully. We're saying, but if you use bio-based materials, make them count as if it was recycled materials. It's equivalent. You're not using any black carbon anymore. Yeah? Because that's the problem in the end. Greenhouse warming potential is using fossil fuels to make something out of it. So, in terms of carbon neutrality, let's make them equivalent, count equally strong in the benefits or carbon points that you get. And what is also important is, let's please not confuse people. I'll have an example of that. This is a bottle that is bon pour la planète. It's good for the planet. So, you can recycle it, it says, and then it becomes paper or a bank, like a chair or a seat. Now, it says also that the cap is made out of bio-PE, probably, but it has paper and an aluminum foil in it. So I'm not sure exactly how this is going to work, but apparently the Tetra Pak guys did a good job, at least in the marketing department. So, and then you see all the logos here? It's unbelievable, huh? So our point is also, if we want to make this happen, let's make sure that the labeling is super simple and clear. This goes here and that goes there, and nothing more, yeah? So that's one other recommendation. And another thing that we are at least discussing also on the political level in Brussels is the EPR fee, the Extended Producer Responsibility fee. Let's please use it to upscale the infrastructure, yeah? Because that's what we need to make it happen. Yeah? Thanks for your attention. I hope I wasn't too boring. Some of you know me, but yeah, thanks.
Thank you, Keith. So, inspired by nature, piloting the biotechnologies, scaling up to bioplastics, and now let's go to the future with new technologies to feed the planet. Adriana Casillas from Tebrio, she is the CEO, will tell us the fantastic story of her project, which is building up her first largest insect plant in Spain.
Okay, so maybe I can use that one and that's it.
Don't forget the Slido if you have some questions.
Sí, sí, sí. Ah, no sé cómo va esto. ¿Así? Sí. So it works?
Yes.
Okay. That's fine. Thank you. Well, thank you very much for being here. I'm pretty happy of seeing you in person finally. Today I'm going to talk about Tebrio and the history of Tebrio. What is Tebrio? Well, today Tebrio is the world's leading biotech company regarding to the breeding and processing process of insects. So what we did is to develop an innovative technology in order to transform the insect in different kind of products, but also in a very sustainable way. Well, Tebrio is not a very old company. We started in 2014, but the idea was in 2012. So what we try to do is to create a new process or a new industry that could help the problems that we are having in humanity. We are talking about climate change, we are talking about being more people in the world, and also we are talking about the problems that we are having with food materials. The planet is not going to be bigger, and we are consuming more and more, and we need to do it in a sustainable way because, well, the climate change is there. It's not going to go away, but we can try to retard it a bit. So, okay, here is a video. This is the spirit that we had at the beginning of Tebrio.
Are you ready for change? Humanity needs leaders capable of inverting the order of things. Leaders committed to sustainability, with new production models, with technology, innovation, and commitment. Our vision? To be global leaders using sustainable insect-based industrial solutions to restore nature's balance. Tebrio, redefining the global value chain.
Okay, I don't know how to. Okay, so yeah, when we started with the project, of course, we called administration, and they were like, okay, but you want to do what with what? So we had to go to Brussels, we had to work with the EFSA, we had to work with the European Commissions, we had to work also on a political level in order to open markets to introduce a new material. So today, we can use our products that are proteins, fats, biofertilizers, and chitosan for different markets. This didn't happen until 2017. So we are using the protein and fat for animal feed in pet food market, in fish, also in agriculture, and pig and poultry. These kind of products are pretty interesting because they are natural products, but they have also different kind of functionalities. For example, using the protein and fat gives to the animals the power of having more than 90% of digestibility of the products, and that means that also these animals are having less waste. So also we are talking about the organic fertilizer. This is the first product in the world of us that has the register for using it as fertilizer in worldwide, and is a pretty interesting product too, because it is not about to work on giving food to the plant. It's about giving food to the soil, and we are having results with clients, I mean not laboratory ones, that we are having productions more than the 40% compared with chemical products. So that's pretty interesting for the market. And we also are extracting chitosan from the adults, from the beetle. So this chitosan has different properties, as for example, we are using it for bioplastic to try to extend the life of the food. For example, we are talking about salmon or shrimps or etc. And also, it is very good for other kind of markets as pharma to try to when you have like some kind of skill, some kind of debt in the skill, it will help you to get better in sooner. Well, we were on this Valle de la Muerte, the Valley of Health, but now we are like scaling up this kind of business. You have to scale it because the market is so big. So we cannot stay in low quantities. So today we are already building that we call O-Farm, that is the biggest insect farm in the world. It's 80,000 square meters of production of insects that will allow us to go to the market with 100,000 tons per year of these products. And also all this production system is based on in-house developed technology. The technology, we don't sell technology, but we need industrial technology in order to produce all these kind of products. But the thing is, when we started, there were no one that could sell us the technology. So we had to develop the technology, also thinking in our own model process. So we invented basically a new industry. This installation is also connected to Europe by rail. So the train is going from Lisbon to Malmo. So we decided to stay in this place, I mean in this area, because for us it's very important to take ethical decisions in our company. So that was one of them, and also, of course, the technology is patented in more than 150 countries. So here is another, just to see how it would be, the offer. How can I? Okay. So yeah, sorry. So yeah, what is happening in terms of numbers, the use of natural resources by Tebrio? Well, using insects, it is a very nice idea in order to work for the sustainability. But I mean, for example, to create or to produce 1 kilogram of other kind of protein, for example, beef protein or pork protein, we need to use, in compare with the Tenebrio molitor, we need to use 95% less land, 98% less water than any other agricultural and livestock farms. Here we are talking also about the vegetable farms, okay? It's not only about livestock. And to obtain 500% more protein than if we extract it from the livestock or from vegetables. So all of that also is in a circular economy model or circular production model, we'll say, because the life of the insect starts with an egg, then it converts into a larva. After that, it is a pupae and beetle. The beetle makes their reproductive things, okay, and start again the cycle. So we extract the protein and the lipids from the larvae. The ophros, that is the biofertilizer, is coming from the excrements of larvae and beetle, and the chitosan, it comes from the beetle. So for example, in our LCA, we found it that if we need to use 6 kilograms of byproducts to give feed to our insects, we will have 4 kilograms of ophras. But ophras, if goes again to the soil, to the cereals, we will produce 20 kilograms of cereals. So that means that at the end, we have zero or negative, I will say, negative footprint. What that means? That means that it is better that our project or that our company or that insects stay on the environment that isn't. So yeah, here is a slide where you can see the CO2 equivalent emissions in different kind of livestock. As you can see, the buffalo and also beef are the ones that makes more emissions. Another ones, as for example, chicken, are the lowest one with 31. In our case, as we are not, we don't have methane or ammonia emissions, we at the end we have a number 2 there. Okay, so our average is 2. And yeah, thank you very much. And yeah, thanks.
Thank you, Adriana. And I think we have the perfect example of what we would call a regenerative circular economy. From 10 kilograms of cereal, we get 20 kilograms of cereal at the end. So that's a fantastic result. So good luck, a lot of success for the project when the factory will be up and running. When is it planned? In 3 years. We'll be there. Hey, Adriana, you invite us for the inaugural. Okay? Good, thank you so much. Please come and join me for the panel discussion. We will keep the panel discussion anyway. And do we have some questions on the Slido? Yes. We have questions. Yes, we have one question. Bio-based material has been criticized for competing with other societal uses and land and having new environmental impacts on aspects such as water use. How do you counter that? So thank you. That's the question that everybody has when we are talking about bio-based plastics. So who starts?
Maybe I should.
You should, please. We listen to you.
It's actually a very good question because I think we need to always keep that in mind. Now today, and I can only talk about bioplastics because I don't know much about fuels or energy in general.
Micro.
I'm not very used to microphones. So, if we would convert today 10% of all the fossil plastics into bioplastics, we would still use only 0.something% of all the arable land in the world, and we would still only use a very, very small fraction of all the water that is needed for agricultural purposes, for instance. These numbers have been checked and verified, which doesn't mean that it is an excuse to just go about your stuff and not think about it. I mean, it's important indeed. I believe that we keep this very well in mind. So thanks for reminding us. I think when you look at the efficiency, for instance, in which biofuels are made from foodstuff, from agricultural products, there's still a lot to gain there. And transport and energy sectors are much, much more CO2 intensive than bioplastics. So Yeah, we have an obligation. We need to have a safe and sustainable society, and water and land use, both of them are also part of that equation. But I'm not too worried about that at the moment.
Thank you, Keith. Then we have Park the question. No, it's a serious one, of course. And it's really the dilemma with how to develop the bioeconomy, the biosource material without impairing the access to food resources. Florian, you talked about the cradle to cradle in your presentation. Do you have a quick definition of what it is?
I don't know if the people here in the room are familiar with cradle to cradle. It's just it's basically more or less a philosophy, I would say. It's more like principles that were built by Michael Bromgart and who's the other guy again?
Bill McDonald.
Bill McDonald, okay. Sorry for that. Creating also the EPA based in Germany, who's basically the labeling company. And so the principles are the following: is that whatever you produce becomes a nutrient for something else. That means that this is basically the base principles of circular economy. So that means, like, whatever you produce will one day become something else, like a nutrient for something else. So there are different kinds of ways for these nutrients. It could be biological nutrients, so going back to the biomass. So we mentioned something about the PLA is one of them. But also it could become more like a technology or industrial nutrients, and it could come back in the loop by, if you're shredding and remaking or chemical, let's say, depolymerization is also a way of doing it so that you can come back. And this is the case for many, many products, because in Cradle to Cradle, it's not only about chemical or chemistry, it's about any kind of products that could be labeled. Yes, this is it. I don't know if I answered well.
Mm-hmm.
Clear?
Yeah. Thank you. Again, PLA. So, from sugarcane, are there other sourcing possible? But I think you are considering shifting to waste or other sources.
I did not present that last slide because we were running out of time a little bit. But I think, like the question on water, also here, it's definitely important to be prudent about this. And today our problem is that if we think about alternative sources like second generation biomass, which is not competing with the food chain at all, because we're using waste streams, for instance, using bagasse or any other waste stream from food or other industries, it's simply not there. I mean, we get the question a lot. The technology readiness levels are only 3 or 4 maybe. It's not available at scale and it's not economic. So yes, we're working on that, but that is probably still 10 years out before we get to real industrial scale second generation feedstock for fermentation of lactic acid in our case.
What about the recycling of linoleum and the part of linoleum compared to PVC that are in majority in flexible footings? Aha. In the bottom.
Okay. So basically, when we talk about recycling is, okay, the principle of coming back to CO2 impact or CO2, are within our industry. Something like is like 70. How much percent is like some 70% of our CO2 emission comes from raw materials, either extraction or land or incineration. So basically, what we consider is that around us, and when I say around us, like everywhere around us, like in any buildings that you can see from here to whatever, there are some materials there. There is material there that we could be calling back and reusing for making new ones. So that's the main principle. So of course there are many hurdles behind that. What's into the material? Is it like is there glue? Are there debris of concrete? Are there bad things in them, like some phthalates that we don't use anymore but were used at the time? Some some, for example, some bad pigments that were banned since the REACH regulation was put together, because again, we have some materials that are being used in hospitals for 30, 40, 50 years. So you can consider that they're out there for quite a while. So of course, there are a lot of consideration. Now, the difference between those two is that, well, on the one side, you have a linoleum, which is a bio-based ingredients material, but then it's being recycled and recalled the same way that a vinyl would be done. Yeah, I mean, it's just that, you know, we recycle linoleum into linoleum, like, so it's the cement that we produce for making it first, like virgin. We recycle it like as a charge into the new ones. And vinyl, we actually purify the vinyl into new pellets after depollution, you know, dedusting and all that, and making just new floor out of it. It's just like a new one. So, I mean, I don't know how to really, you know, it's just like two, I mean, you can't mix those two together. It's like one process on one side and one process on the other side. So there's like one plant in Italy, one plant in Sweden. So they are really separated processes.
But both are recyclable and
Both are
collected
recyclable.
by,
They both are, you know, and our real
in the
challenge today
Restart
is
program.
rather to collect those materials. So we were talking about consumer being part of the equation. There it goes.
Thank you. Tanya, I think it was a great story, a great support that you offer to innovative solutions in the biotech, but what are the main challenges and hurdles, and how do you overcome them when you are running such projects for scaling up and crossing the valley of death?
That's the easiest question. So yeah, the main challenges and hurdles and how to overcome them. So actually the idea of to reduce the risk, the technology risk, is really to make use of the available shared pilot facilities that are available in Europe. So of course, Bio-based Europe Plan is not the only one, but it's, yeah, we have a lot of experience. And yeah, it's really to approach shared pilot facility early in the technology development. So because what we often see is that startups or SMEs are entering our door with their protocol, and then actually they have already a fixed idea in mind what they want, and then they come to us and we evaluate, we do the technology transfer of their idea, of their biomass conversion, and it's not going as quickly as they hoped for, and it's taking up a lot more budget actually as they also had in mind. So I think expectation handling is also one of the key elements, and that expectation can be handled when we will be approached very early, so that we really can accompany the startup or the SMEs from a very, let's say, unmature TRL. So we started TRL 4, which is just out of the proof of concept, setting it up in an industrial environment, and then accompany the company from TRL 4 to 6. So TRL 6 means actually that they have enough application material produced to approach the investor. So because every development needs a lot of budget and not a lot of resources. So if they can convince the investors, and not only one investor, probably a lot of investors, so they actually can pick their best match from the investors, that they can only show this with application material, but some investors or end users, they're not asking for grams of the application material. They need kilograms or tons, or let's say kilograms, couple of 100 kilograms to test the application material. So, and also, yeah, it's not only about developing a process, it's also, as I said before, defining the purification process. So in terms of technology development, very often the startup and SME has an idea how to ferment certain biomass and which product they would like to end up, but they have no idea how to come to this refined product in the end. So We do mostly actually a lot of downstream purification for the SME.
Thank you, Tanya. Adriana, I had a question. It's more about culture and how we would shift to next steps. For the moment, you are providing solutions and products for animal feeding. Do you think that in some future, the proteins and material that will be produced from the plant could be used for human nutrition? And do you think that the cultural change would be easy for people to accept it?
Well, of course, the food market is there, but we actually don't have enough information about the global ratios that we could have there. Even though, if you ask me personally, I will say that the only way to eat insects in Europe is doing it extracting the proteins and adding these kind of materials to pastas or to other kind of food that has some kind of functionality too. But even though, I mean, it is not about what happens in Europe, it is about what happens in the world. And in the world, there are a lot of people that are making their lives on agriculture or on livestock. So in my point of view, there is no way that the livestock could disappear. Okay, because we are not talking about if we can pay a plant-based ATC hamburger, that we can, and great if we do it. It is about the population worldwide. So what we are trying to do is to make an impact on the base of the value chain, of the feed value chain. So all these kind of livestock or all these kind of agricultural actions, etc., could be more sustainable thanks to our products and to our new industry. So we impact directly in a very sustainable way on this value chain. So that means that at the end, the LCA of the final product will be more sustainable.
Okay. Thank you. Yes. Allez. Come on, Keith. This is for you.
Yeah, as you already noticed, I like provocative questions, and this is definitely one. I have a very simple answer to this one. We have been bio-based for a couple of million years, huh? And then for about 1 century, we got really drunk on oil. And now you can debate whether we have reached peak oil yet or not, but that will end at some point. And let's be smart about it. Let's make sure we end it instead of it ending us. Yeah? So bio-based is the norm. Oil is an exception. Yeah? So this is not a question, this is a task we all have. It's a challenge. This has to happen. It's not a question, it's a statement. This needs to happen. So other people say the Stone Age didn't end because they ran out of stones. Yeah, well, we didn't run out of oil yet, but let's make sure we make that conversion really very fast, because otherwise we are in dire straits, I would say. So bio-based should be the norm, and fortunately we have learned a lot in the meantime in very efficient production systems and circular thinking and all that, because nature doesn't waste anything. In nature, everything is reused. So let's just copy and bio-mimic what nature has been doing for a couple of million of years. So thanks for the question.
Should it be le mot de la fin? Yes, very good one. It's a very good one. Thank you very much for joining. Thank you, the speakers. I think now we have time to have drinks and hanging around, discussing, networking, and having a coffee if you want, Keith. Thank you very much.